In this video, we'll be trying to see what we mean by a serial schedule and a non-serial schedule. We'll be trying to understand these terms. So, now imagine there are two transactions, T1 and T2. These were the same transactions we had seen in the beginning of the module. So now imagine there are two transactions, T1, which the operations on T1 is like we read the item X, we reduce N from that, and that is updated by doing the command write item X. We read item Y, add that N that was reduced from X to N, then write item Y. So this is one transaction. Another transaction is like we are reading X and adding M to that, and we are updating that X by write item X. So now from what we have understood till now, we know that if T1 transaction occurs first and then T2 occurs, there won't be any conflict or issue happening. Or the other way, vice versa, if T2 occurs first and then T1 occurs, then also there won't be any issue happening. We will be getting the same result. We have seen that. So if so so such schedules where like the one transaction is completed before the next transaction begins, such schedules are termed as serial schedules. Hope you remember what a schedule was. Schedule was the order of operations when there are more than two transactions happening. So if T1, the transaction T1 is completed before T2 starts, or it can be a serial schedule. So the schedule A that is shown over here is an example for a serial schedule. This schedule B is also serial schedule. Here transaction T2 completes itself before transaction T1 begins. So this is also a serial schedule. Now let's see what we mean by a non-serial schedule. So we had seen like in the beginning of the module, like transactions occur in an interleaved fashion or concurrent fashion. That we have no control over like two transactions occurring. So they can occur in an interleaved fashion. So in this such schedules, like here the transaction T1 is not getting completed before T2 starts. So they are occurring in an interleaved fashion. Such schedules are actually termed as non-serial schedule. Here the one transaction does not start after one is completed. They both occur simultaneously. Such schedules, so schedule C over here is non-serial schedule. So hope you got what we mean by a serial and non-serial schedule. Another example of non-serial schedule. Here transaction 1, a part of transaction 1 occurs, then a part of transaction 2 occurs, then again the rest of the part of transaction 1 occurs. Still they are occurring in an interleaved fashion. That like T2 is not waiting for T1 to get completed. So such schedules are known as non-serial schedule. So in real world also we cannot guarantee serial schedules. Let's see why this non-serial schedule is so important. Now just imagine you are trying to book a ticket, a railway ticket, or you are trying to buy something from Amazon. If serial schedules were followed, if someone else is purchasing an item or someone else is there on Amazon, you won't be able to view or purchase that item. A message would have been shown, okay, wait, someone else is trying to purchase this. Have you ever seen such a message? Or a message would be shown, wait, someone else is trying to book the same ticket you are trying to book. You are never shown such a message. If so, it is like multiple transactions are occurring simultaneously. So in real world, most of the schedules would be non-serial. Now our concern is, let the schedules be non-serial. So now we are coming to the next term. So we said like we can never guarantee that schedules would be serial, but one thing we need to guarantee is that even if the coming back to the example, let's just see actually if these two transactions are executed and there is no conflict going to happen between these two transactions, and if T1 occurred first, completed itself, then T2 occurred, things would have been fine. We would get the correct result. Or even if T2 occurs first and followed by T1, we will be getting the correct result. But now the issue is they are occurring in an interleaved fashion. So our concern now is let them occur in an interleaved fashion. Will they produce the same result even if they occur in this interleaved fashion? That is, one example was this was an example of non-serial schedule, this was another example of non-serial schedule. If they occur in this fashion, will they produce the same result as the final answer, or will we get the final answer the same as the serial schedule? Like if schedule D and schedule C, will they produce the same answer as either schedule B or schedule A? So schedule A and schedule B are serial schedules. Will schedule C and schedule D give the same answer as the serial schedules? So that is the question that arises. If they produce the same answer, then things are okay. Let them happen in a non-serial fashion, but we should be getting the correct answer. But that doesn't occur always. So the question is whether the schedule is serializable. So we are coming to a new term, serializability of a schedule, or the question asked can be whether a schedule is serializable. We can say a schedule is serializable if it produces the same result as that produced by its equivalent serial schedule. So we would like to determine which of the non-serial schedules always give the correct result and which may give the erroneous or the wrong result. So the concept used to characterize schedules in this manner is known as serializability of a schedule. So hope that is clear. So see, we can say a schedule is serializable if the non-serial schedule produces the same result as that of the serial schedule. So coming to an example, so we had seen 4 schedules, schedule A, schedule B, schedule C and D. So let's see one by one. Let's take an example and see. We know that schedule A and schedule B are serial and will produce the same correct result. So what is left is to see whether schedule C and schedule D will produce the same result as schedule A or B. Let's see, let's check that. And for our example, we have taken some values like x is 90, y is also 90. So keep that in mind. X and y are 90. N, capital N is 3, capital M is 2. So if you execute the serial schedule, like x is 90, if we reduce n, that is 3 from that, and write item x, if we do, we get x as 87. Then we read y, add n, that is 3 to that, we get y as 93. Then t2 happens, we read x, so x now was 87, add m to that 2, so 87 plus 2, 89. So the final value for x and y produced in this serial schedule is x we get as 89 and y we get as 93. So that is the correct result we should be getting. Even if we do in this manner, t2 first and t1 later, we will be getting the same result. Just see, x we read plus m we do, so 90 plus 2, 92 is x. Then we read x, which is 92, reduce 2, so reduce 3 actually, n is 3, so 92 minus 3, 89 is x. Then we read y, which is 90 plus 3, 93. So we are getting y as 93 and x as 89. So these two produce the same result because they are the serial schedule and we expect to get that result. Now let's see what happens with schedule C. Please try to concentrate on this. In schedule C, we read x, so x is 90. I've just written the values over here. X is 90. When we do x equal to x minus n, bear this in mind, x is updated only when we perform the command write item x. So x equal to x minus n, it is just a temporary variable. So x is read as 90 over here. Nothing is updated. Again, when t2 tries to read x, so now things are occurring in an interleaved fashion. When t2 tries to read x, it is again getting the value of x as 90. Okay, why? Because this write item x did not perform over here. So t2 x is read as 90. We add m to that. So adding m to that means m is 2. So 90 plus 2, 92. So after that, when write item x occurs, x value is 92. Okay, so now x is written as 92. Then we read y, y is 90. Then again a write item x occurs. So write item x again occurs means the last value the variable x has is 92. So 92 is the value for x. Then y was 90. When we do y plus n, that is n is 3. So 90 plus 3, 93, and write item y we get 93. So y we got the as 93 itself. We had to get 93 based on schedule A and schedule B. But x we got a wrong value. X we had to get 89, but we are getting 92. So we are getting a wrong result. We are not getting the same result as that of schedule A and schedule B. So we cannot say schedule C is serializable. Hope you are getting what we mean by serializability of a schedule. So the schedule C doesn't give the same result as schedule A and schedule B, which are serial. So schedule C is, even though it is non-serial, it is not serializable. We will see what a serializable schedule is by you looking at schedule D. Now you can see that schedule D is non-serial. It is occurring in interleaved fashion. Let's see the result it is going to give. So read item x is going to be 90, x minus n will be getting 87. So write item x command produces the x value as 87. Then T2 takes over, read item x is 87 plus m means 89, write item x 89. So x is updated as 89. Read item y 90 plus 3 93, write item y 93. So over here we get x as 89 and y as 93. So in the schedule D we are getting the same result as schedule A and schedule B. So even though schedule D is occurring in a non-serial manner or an interleaved manner, it is producing the same result as that of the serial schedule, schedule A and schedule B. So schedule D we can term it as serializable. Schedule D is serializable. So hope you got what we mean by serializability of a schedule. In this, schedule C was not serializable and schedule D is serializable because it produces the same result as that of schedule A and schedule B. Now another question can arise, can two schedules that produce the same result, can we say they are equivalent? Or if they give the same result, can we say they are serializable? It's not always like that. Say in this example, S1 S2, if these are the two schedules, imagine they are two different schedules. Over here x is read, say x is 100, and if we add 10 to 100 we get 110 on right item x. Here if we read x to be 100 and multiply x, that is 100 by 1.1, we'll be getting 110. So x over here is also 110. So actually S1 and S2 is giving the same result, but we cannot say these schedules are equivalent over here. They are not equivalent because they do the different operations. So schedules, when we consider schedules, as we saw in this example, they should be doing the same operations. Only then we can compare a serial and non-serial schedule together. So in this session, just see that whether you have got what we mean by a serial schedule and non-serial schedule, and how can we check whether a non-serial schedule is serializable. Hope you got that. Thank you.